So that's the exploratory, and let's get into the main topic of today's seminar, which is the factor data type. So today's topic, I'm going to touch the data wrangling. Data wrangling is to transform or clean the data. So the factor data type is sort of like you want to set the data as a factor data, and you want to manipulate the levels in a factor data type and so on. So it's heavily or mainly involved in the data wrangling step. But why you do the data wrangling is because you want to visualize the data, because you want to analyze the data by using analytics algorithms. So like I'm going to touch a little bit of visualization, a little bit of analytics as well. Okay, so what is the factor data type? The factor data type is designed for storing the ordinal data. Ordinal data is basically categorical data with order. And then like you can set the levels explicitly, and then that means you can manipulate the levels. And then this becomes important when you start building the statistical models, because they heavily rely on this thing called base level. So I'm going to talk about, explain more detail on each topic. So what is categorical data type? Like I just kind of casually mentioned that. So that in the data type in Exploratory, by the way, Exploratory is a UI for R. So like we follow all the data types defined in R. So, but R is the programming language for doing data analysis, but it's designed to do data analysis. So it's heavily, all the data type in R are designed to help us or help you analyze the data. So it was from the beginning, it was designed for it, so, right? So it's not like kind of added on like later. So that means like what are the data types in general when you talk about data analysis? And there's a bunch of things, but mainly like we can maybe list up these things, like a numerical, categorical, ordinal, logical, and date and time. And each of which has its own data type in R or in Exploratory, and which can be like numeric, character, factor, logical, and then data and project CT, and so on. And today, like I want to focus on, like we want to focus on this like ordinal and factor at the kind of center. So to understand, because the numerical is like, it's just numbers, right? It's like starting from 0 to like whatever the numbers, or it doesn't have to be 0 to starting point. It can be like a negative too. But the main key thing is the continuous. It's like, you know, for example, 0, 10, 20. And then when you have the 10, 20, like you can expect the numbers between like 10, 11, 12. And even like between 10 and 11, like you can expect the number to be like 10, 10.1, 2, and so on. It's continue, and they're usually like kind of endless, like on either side. And opposed to that is a categorical. The categorical is there's no continuous relationship. So let's say like we pick like a United States state, and then Texas, California, New York, and so on. And then there's no continuous, there's no like Texas point one between Texas and California and such things. And also typically like limited set of values. So let's say like we have only 5 states, or in 50 states, 51 states, or whatever, there's only limited set of values. While not numeric, which is like a kind of endless, it can be like hundreds or thousands, you never know. And then there's no ordinal relationship in this categorical data. So for example, Texas and California, by looking at just Texas and California, there's no way to see like Texas is like higher or the California is lower, that kind of stuff. Like you might be able to say it based on the population, some other numerical values, but just by having this text or the character or whatever, this data itself doesn't give us any ordinal information. But in the world, there are some certain things that looks like categories, like let's say really bad, bad, neutral, good, really good. These are like a typical, like kind of a survey question, answers to the survey questions. And then like we intuitively understand the kind of order in these 5 categorical values. So really bad is the kind of like the worst, or like it's maybe like the lowest you can get among these 5 values, and then really good is like the highest value you can get among these 5 values. So there is an inherent ordinal relationship in the data, right? So like this is like as a human being, we understand it when we look at this type of data. Or when you are basically creating the data, like you have this kind of information in your brain, but the computer has no idea. So if you have this data as a character, which is the left-hand side, the computer has no idea like which one is higher, which one is lower. But by making this as a factor data type, then we as a human can set the levels. Let's say like really bad is 1, and bad is 2, and neutral is 3, and so on. Then the computer can use these two information, like which is a name and a level, to decide like, which one comes first, which one comes later, kind of stuff. So that's the factor data type. So then once we define as a factor data type, then the chart can give you this kind of visual format. So like when you see, like these 5 categories, like you expect the chart to sort it in this way instead of like alphabetical order or like based on the values on the y-axis and so on. And then one thing is that once you define that as a factor data type, then the first level, like your right-hand side, like is a level column. So imagine, think of it like this whole category and the name and the level can be combined together inside the system. But this like a level column, like 1, 2, 3, 4, 5, that's the order numbers that you can set. But whatever the one has a level 1 can be considered as a base level. Again, this concept becomes important like when you start getting into statistical learning model. I'm going to touch that towards the end today as well. So when do we need factor data type? When should we care? Well, you don't have to have it. Like most of the time, not most of the time, like in many cases. But when it comes to like sometimes visualization on a certain types of things you want to do with chart, or you want to do something called binning or categorizing the numerical values, or like you want to start working with the statistical models, those are the time like you want to think about like using the factor data type. And then let's start one by one. So get into the examples, right? So here is the typical, kind of typical survey data. You can download this from the Kaggle website. They interview the data scientists. Like a survey the data scientists. And then towards the end of, at the end of 2018, and then they got the result. And then, so I got this data, and then one of the column is talking about how the data scientist thinks, how do they think about online learning platform, such as Coursera or Udacity, and so on, compared to institutional or like a traditional academic institutions. So let's say like some university or college, in terms of like how efficient you can learn about the data science or data analysis and stuff. Okay, so therefore there are like I think like 5 answers, like a multi-select or no, not multi-select, like single select, but like basically like people who are surveyed basically select one of the options of 5 or something. So if you go to summary view, like you get something like this. So it's like a slightly better, much better, nicer, and so on. And this bar chart in the summary view are sorted based on the frequency or how many values of each. So slightly better is the highest because they're 4,554 people answer with this option. But so basically, sorry, not bad. If you basically create a bar chart with this and it's sorted by the number of rows, or in this case, number of the people or number of data scientists, then you get the chart like this, and it's starting from slightly better, much better, and so on. And so this one is you can understand like which one has the highest people, but there's some kind of a weird thing for us as a human being. And then if you don't sort And then in Exploratory, like you can select like not sorting, meaning it's going to do the default sorting, which is to sort x-axis based on the x-axis value alphabetically. So then much better, much worse is coming left, and then slightly worse going right. That's because alphabetically M comes first, and N and S and so on. But what we as a human being want to see is something like this. So in this case, much worse, slightly worse, neither better or worse, slightly better, much better, because this way, like we can kind of like understand, like sort of like going from left to right is like an answer, sort of like level of the quality of the, in this case, online course, online school are evaluated, right? So like it's like the right hand side is better. Basically, like people think it's like online classes are better than the traditional schools, and then going to left hand side is traditional is better than the online school. So like it's much easier to see this this way. So so how can we do it? So that's where the factor comes in. So this is like a first example. I'm gonna have I have like a 4 examples, but this is the first one. And then before doing so, there is a package called ForCat in R. And then this ForCat is super amazing. It's about, this is a package to work with the categorical variables, or in this case, the factors, right? So, and then like by using some of the functions from this package, that you can flexibly and quickly manipulate the levels, or correct the levels, or set the levels, or whatever you can call it. And then if you're interested in, I highly recommend you to go to this website, which is the homepage for ForCats. And then there are a number of functions, and then there are more functions than listed here, but I'm going to introduce these functions from the top. Okay, so the first thing, going back to the Kagel's data science interview or surveys, like we want to set those the values, right? Like answers from much worse to much better. So how are we going to do it? In this case, let's set those levels manually. When I said levels is sort of like order number or something. Think of it. So to do, I'm going to just let's do the demonstration here. And then so here's the Kaggle DS survey data. And then there are a bunch of columns. It's actually, I selected only certain columns because there are tons of columns. I think it was like a 300 to 400 columns. So like I selected some of them. If you're interested, I'm gonna have the link to download this data at the online seminar page later. So here, what I'm interested in is where's that? Here we go. This column, and then okay. So here, looks like I have already sorted. So I'm gonna just delete this and pretend like we haven't. So here, online learning platforms and MOOC is like like I think it stands for, I forgot what exactly it stands for, but it's about like online classes or online university. But anyway, so here, so it's like a slightly better, much better. And then like if I just create a chart, and then it comes kind of like this, so like a slightly better, much better. There's NA, like I don't want that NA, so NA is not really helping here. So like I'm gonna just take the NA out. This has nothing to do with the factor, but it's more to do with kind of like visualizing the data. So I'm gonna just remove that NA. So it looks nice, but still like this order is not really like intuitively sorted. And because like a sort by is right now is used, it's using the y-axis value, in this case, the number of rows. So I'm gonna just take this out, and then now it's sorted by alphabetical order. Then this is still not what we want. It's like a much better, much worse. Yeah, it's like a super confusing. And then, so now like we want to set the order. So like you can do from the table or summary view either way. Let's go to summary view this time. and then from the column header menu, and then there's a set order for values. This is, so most of the factor related functions are accessible from this menu. And there's one exception, which is like a create other group. But today, like we want to focus on like manipulating order. So like most of the stuff is here. And then first, like let's use manually this case. And then it populate this like FCT underscore read level, like resetting the level. And then like the first one is the column name, in this case, online learning platform and blah, 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 and the MOOCs. And then you can select the value from this column and then to set the order. Whatever that comes first becomes like the higher first order of the first, second, third, and so on. So here, what I like to do is I want to start with much worse, and then slightly worse, and then kind of neutral, which is like neither better or worse, and then slightly better and much better, and then no opinion, I don't know, which that is should be like kind of outside. So let's start like much worse. That's the horrible. That's the worst one, right? And then next one is slightly worse. So I'm gonna select it. And then like as you see, like I'm just typing the comma to kind of like listing up all those values. And then so now next one is neither. And then it's like a slightly better. And then much better. And I can set like another one here, or like I can just leave it like here, like because all I care is that these 5 values, and anything else is sort of like should be going somewhere else, not somewhere else, but like after. So I'm gonna just stop here, and then I'm gonna just use a command key and enter to run it. And then like you see, like here is like there's a mutate step. And then what it does is like exactly like by using the FCT relabel to set those values in this order. And then you see like this factor as a data type, which is different from character. And then when it's character, like you see this chart is basically sorted, the bars are sorted based on the frequency of the value. But it's factor, then it respects the levels that are defined in this factor data type. And then you notice here is a base level. The base level is nothing but it's just a first level, in this case, much worse. Okay, and when you have this, and then like you go back to the chart, what? Oh, here. When you go back to the chart, and nothing changed because the pin, you remember this pin bottom is not set to the latest step that we just added it. This is the step, and then step 6 is where like we set the level. So I'm gonna have to move this pin by drag and drop. And then now this data, the data we are seeing, the chart view is coming from the step 6, which has this factor data type for this column. So therefore, like x-axis is now sorted. Let me just make a bigger screen. So here, sorted by much worse, slightly worse, and so on. Okay, so that's simple. And then let's go to the next one. So here we go. And the one thing though, I kind of like said it briefly, but what I actually did is set the levels for those values, but I didn't set for like the value called no opinions or something. And then what's going to happen is that it internally, when I run that function, whatever the ones that are not set for the levels are going to be sorted alphabetically and then be added after the ones with the level. So in this case, this 6, like 1 to 5 are already set, and so 6 is available. And so no opinion is using the level 6. If I had 3 or 4 more values, then those are going to be sorted by alphabetically in an alphabetical order. Then given the value level number of like 6, 7, 8, 9 or something like that. Okay, so so next one is the setting the levels as is. And so let's take a look at this one. Is also, I'm going to just jump into the, let me just show quickly here. So I have this like a president, US president data. So like, all historical US president data. So like from like George Washington, John Adams to Donald Trump today. And then each row has like a year. So like from 1789 to 2019. And then, so like basically the mapping of the president name and a year. And then like when you visualize it, like what are we visualizing here is like this like a number of rows is like each year is a year. So like a number of years they served. So Franklin Roosevelt served for like 12 years, and then Grover Cleveland also served 12 years, and so on. And then so now here is, it's okay to with this chart, but if you are interested in seeing sort of like who has served more than others, and all you care is sort of like a number of the years, and then this chart is great. But sometimes you want to see them sorted by the year that they served, not the number of the years. Just that, like, so for example, like Barack Obama should come before Donald Trump, but after George W. Bush or something like that. So if you don't sort, then like this is what you get. This is like alphabetical order, and this is completely not something that you want. Instead, you want to have something like this, starting from George Washington, John Adams, Thomas Jefferson, and so on. So if we have the requirement like that, then we can actually set that way. So luckily in this data, let's go in exploratory again, and then there is here this like a president data. So here, this is the one like I was showing the slide, and then luckily like we have this year column. So what we can do is this one too. I think like let me just delete these steps. Okay, here, and then we have the year column. And then, so first, what we could do is we can arrange by the year. So making sure this data is sorted. And once it's sorted, and then based on this, because we now know this, all these president names are sorted by the year. So that's how we want to set levels for the presidents, right? So then we can actually go to the column header menu, and then set all the values. And then there's an option called as is. This is going to set levels for these presidents based on how they appear in this data. So George Washington will become first level, and then John Adams becomes second level, and so on. So as is option is to respect the order already presented in the data itself. Then there is a FCT underscore in order. So in order is basically the as is option. And then I'm going to override the original text president column. So like I'm going to just quickly run it. And then you notice like this data type becomes factor when I go to the summary view, and then I can see the first 7 president in that order. And then when I go to the chart, and then let's say, let's use a bar chart or something, and then I can show the president name, and then Y is the axis. Then what I can do is horizontal. It makes it easier to see. Here, notice that like this president names are sorted alphabetically, and that is because this president column is still which is character. So if the pin is still at the step 8, I want to move this step, a pin step to step 10, because this is where we change the order. So now we see like George Washington, John Adams, and at the very end is Barack Obama and Donald Trump. So that's what we wanted. And as a bonus though, here there's another way. So once you define this, for example, this is just a mapping table, right? But once you define this, define this like a president column to be the factor, it doesn't have to be the president. You get any kind of data, product name or customer or region, or country, anything. Once you create this data, then you can use it with other data frames. So for example, I have this beer tax data, and this is super interesting. So here, let's see. So I'm gonna just select this, pretend like we didn't have this one. So like right now, like we have this, this is like a year and then like a tax rate. And then this is a tax rate for the beers. I think this is like a federal level beer tax or something. And then like I want to see like how this tax rate has changed, over the, I don't know, it's like 100 years or like 150 years or so. So when I go to the chart and then selecting the line chart, and then, the pin, I want to make sure pin is the last step. Okay. And then the year and the y-axis is the rate. And then this is basically the historical kind of movement of the tax rate for beers. And then now, like, I want to see like which president has raised the tax or decreased the tax. Most of the time, like it's kind of raised the tax. So now, like, I can bring the president data, but also like I want to show the president names in that order, right? From this older one to the newer one. And then what I can do is I'm gonna join this data frame with the present data frame. So select the join, and then like, I'm gonna select the president here. Then like year and year. So like I'm using these two columns to match and then join. And then like I got this like president names here. And the cool thing is like now like president name, this column is a factor data type. So that means if I use it in the chart and then it respects this order. So what I mean, so when I go to the chart and making sure that pin is moved to left join, so that like the data we are looking at is going to come from the join step. And then like I can assign the president name to the color. Ooh, what happened here? There was kind of a weird blue color, which is the others. And then like this color automatically leave only I think the first 20. And then like the others like a value to be, they put other values to be like called other group. So what that means, so if I click on this green button, this like keep only most frequent or something, and the number of mass frequent. So like if I don't want to, sometimes it's useful like when you are dealing with 200 countries or something, and you want to see only the top 10 or top 20 countries, and then you want to put like the rest of the countries under the other. That's useful. But here, like we have only 29, so let's show all of them. So I'm going to click on this one to uncheck it, and I click apply. And then now we are seeing all those 29 presidents. And then like each color is representing each president. So like we can see that Woodrow Wilson and Franklin Roosevelt and who's this? George W. Bush are the three presidents that increase the beer tax pretty high. So that's and then like the cool thing is here is like these president names are sorted following the original values. One thing notice though here is that even though data starts from Abraham Lincoln, because this data starts from 1862, but the data and the president name itself has all those labels in the factor, starting from George Washington. So from here to there, even though there's no data in this particular for this particular chart, but in the legend you can see. So like you can see like who is in the chart, who is not in the chart, who is supposed to be or not supposed to be. Okay, so that's the bonus. So once I use this a lot, sometimes like I want to define those like order, and like leave it as a kind of, sort of like a mapping table, and then like I use that into with other data frames like I'm investigating or something. Okay, so here, and there are a couple other options also. So you want to set the level. So like we have seen as in order, which is already the order respect in the data. And then the other one is manually setting all these values. But sometimes like you want to use, you want to set the levels based on the data, sort of summarized values. The first one is the frequency. And I'm going to quickly show this one first. So here we have like order data or sales data. And then let's say like we have the bar chart. And then, again, like we can sort this data by sort these countries. So we basically, each bar is representing like average marketing cost for each country, right? And then like, we can sort these countries by using the average marketing cost. So like higher bars, starting from the highest bars to the lowest bar. But can we order this not based on the y-axis value, but kind of a number of orders? So this data turned out each row represents each order. So like basically like what we want to do is based on the number of rows, like a number of rows mean number of orders. And then like we want to set that sort of like a sorting order levels for the countries. And then to do, you can do from like a column header menu, and then you select set order for values, and then selecting by frequency. And then like you will get like FCT underscore infreq, in frequency. So then this one is basically calculate like how many rows for each country. And then from the highest one to the lowest, like I said, the level from 1 to whatever the numbers of countries. And then like, if you don't set the sort by, which then like the chart will respect that factor levels. And in this case, United States happen to have the most rows or most orders, so like it comes most left-hand side. So, and then the cool thing about this, like once you do it, then no matter what column you select for the y-axis, let's say y-axis can be sales, y-axis can be marketing, total marketing costs or average marketing costs, whatever that is, x-axis, you always can expect the countries sorted in the exact same order. And then that sometimes it's better when you're presenting multiple charts, because nobody wants to see like a United States, this time the most left-hand side, sometimes the middle, sometimes the right side. Like you don't want to do that. So like you kind of want to fix the country's positions in the chart, and then like you can present. So that's one way to do it. Another thing is like you basically, the information you're getting out from this chart is that like you see like from the left-hand side is the number of the order is the highest, and the right-hand side number of the order is the lowest. So that means you can see that you can sort of like get information as like, so, hey, right-hand side, those are the countries with fewer orders, but they have the higher number of, in this case, average marketing costs. So you can see some kind of a gap from this chart, because thanks to the country column is being the factor data type, and it's set using another, using the number of rows as the levels. And sometimes though, like the world is not that simple, right? It's like, so using the number of rows is one thing, but typically like you want to use another column. For example, like you're looking at the marketing cost, but you want to use a sales column to sort or set the levels of the countries. And you can do it based on another column option. And then again, like from the column header menu, and you select the set order for values. And then there is a submenu by another column. By selecting this, and then you get FCT underscore reorder. All the factor manipulation function starts from FCT. And then these are the functions that come from the forecast R package. Anyway, so here the first one is a country, and then that's the column. And then the second one is the column values that like, you want to use to set the levels for the country. So in this case, I said like sales. And then if you click run button here, and what is going to happen is that it uses the mean with ascending order. So like basically like there are multiple rows for each country. and how you want to calculate the sales. And the default is to use mean, so like average sales. And also the ascending order, that means from the smallest to the highest number. And most of the time, that's not what you want. Like what you want is you want to set the aggregation function or summarizing function, and also set the order. So you want to set like a dot FAUN and equal sum, and then dot DESC, this is like a descending. So you want to just do the descending, and then you set the true, and this means like you want to reorder the country based on the sum of sales in descending order. So that means highest to the lowest. Then once that's done, then like you get the countries are sorted based on the sum of sales. And then now again, the same thing, like no matter what columns you assign to the y-axis, you always get the exact same order of the countries represented at x-axis. And this is a side note, and sometimes if you're familiar with sum or average, that type of calculation, when you have the NA in a column, in this case, a sales column, and then if you have an NA, it becomes zero because the R is pretty strict about like how to handle the NA things. So you want to set this like NA.RM equal true, or you just filter out all the NA values at the wrangling step, and then you can call this one too. Either way, but this is a way to kind of give option, and the NA.RM, RM is meaning the remove. So like if you set true, then you first remove the NA, then do the sum calculation. So just a kind of tips. Okay, so and the last two topics. First is the window calculation, and another one is like a statistical model. So let's take a look. So here we have employee data, and I'm gonna show the demo and do one by one here. So let's go to here. There you go. And then again, let me just drop these things. Yeah, okay. And then let's go to the chart view. And then like, if I want to see, so this is like a employee data, and each row represents each employee, and then it has a bunch of attributes. One of them is monthly income, and another one is a job role, right? So like a job role, what are the job roles we have is like 9 job roles, right? And I want to see, like, what are the average monthly income for each job role. So I'm going to click on this button to quickly create a chart, and it's already sorted based on the y-axis. In this case, number of rows. I want to select the monthly income, and then not the sum. I want to see it by the average. So this one, the manager, research director, healthcare representative. And these are the orders. So this looks like these 2 job roles makes a lot of money. And then now, like I want to let's remove the sorting setting. So like this is like now like alphabetical order. And then now like I want to see like how much manager is making compared to the healthcare representative, or like I want to see like how much less sales representative making compared to health representative. And to do, like I can actually select the window calculation from the y-axis and select that here. In the calculation type, there are a bunch of few options, and then select percent difference from. And then percent difference from is basically difference between compared to whatever. So in this case, default the mean. So calculate the mean, and then compared to mean, like how much healthcare representative making, how much the manager making in the form of the percentage. But here, like I want to use the first value. And then if I do this, and then that means what's going to happen is all these bars are compared to the healthcare representative, and then show the percentage difference compared to healthcare representative. So click on apply, and then now like I see, for example, managers is like 128% more than healthcare representative in terms of monthly income. And then we don't have anything for the monthly healthcare representative because we are based on this one, so it should be like 0. So now here, like we can see like who's making more, who's making less, and how much they're making more, and that type of information. But here's the thing: is like who wants to compare to the healthcare representative? If you happen to be working in a healthcare representative organization, or like if this is the first the category that you care the most, then this view is probably give you a great insight. But if you're not familiar with the healthcare representative, let's say like we are more familiar with the research director, then like you have no idea like what to understand this information. So what you want to do is basically like you want to compare against the research director, and then but currently you can't set which one to compare to. Like all you have is like a first or last and then other options. So this is where like you can actually use the factor by manipulating this job role column, setting the research director as the first level. Then we can use this window of calculations. How are you going to do that? So let's go to the summary. Again, either way, you can do table or summary view. And then from the column header menu, and then set all the value. And then this time, we already use this option like manually. So I'm going to use the same thing. And then click the tab key to show this list of values. And then here, like I'm going to select the research director, and then just click run button. And then now job role, I set only research director, and I didn't specify anything else. So that's why like other job roles are sorted by alphabetically, and they are given the order ID or level ID 2, 3, 4, 5, 6. So now, but at least we have the base level of the research director here. So that means if I go to the chart view and job role, and then I'm going to move this pin step to this step 2, because this is where like I change the factor level. And then now you see like research director is showing up at the very left-hand side. And then all these bars are representing the percentage difference compared to the research director now. So only the manager is making more, like 7% more, and the other job roles are making less than the research director. But here again, because this window calculation is comparing against first, and then like I use the factor levels to set research director as the first. So this is one way, one place that you can appreciate the power of the factor data type. Okay. And then last topic, but not that least, is by the way, let me just quickly, I created some diagram here, the image here. So what I did was that like used to be like this kind of categorical column, and then I wanted to move the research director to the first. So by basically like I converted character to factor. How did I do that? By using FCT level function. Whatever the FCT function like you use, the function starting with FCT, like the function from FORCAT package, automatically convert from character or even numeric to factor data type. And then in this case, I set only research director. So research director has 1 as a level, and then the other were given the level ID based on the order of the alphabetical sorting order. Okay, so that's what we did. So next topic. Oh, here's a binning. There's a binning also, like, but you can create binning, which is to categorize the numerical values. And then if you do, oops. From here, you can actually categorize the numerical values. And then when you do, obviously, like you want to respect the original, like the levels, right? So that's where, let me just quickly show it to you. So let's say like we have the monthly income, and then like we want to categorize this. So we call it binning, but then like from the column header menu, create bins, categories. And then the default options, there are a bunch of methods, but let's use an equal length. And then notice here at the x-axis, basically they divided into 10 groups. And then so each bar has its sort of like a label, which shows a range of each bar. And then like when you run this, and then that new column is called monthly income category here. And then these values. So it looks like these values are random, but it's actually the factor. And that means it has levels. So therefore, if I go to the summary view, where's that? Here you go, monthly income category. And then it's sorted based on that level. And then when I go to chart view, and these x-axis level, this is like now like a character, or it looks like a character data, but it's actually a factor. And then the number is from the smallest to the highest. So this one is I use for equal length, but whatever the option we use, it always return as a factor because the order is important. But the latest release though, with the exploratory, now you don't, you have less chance you need to do the binning as a data wrangling step because the binning is now supported as part of the chart. So that means if you assign numerical values to, let's say, like x-axis, and then automatically it says CAT, which is the category, it categorizes. And then you can click on this green menu link, and then to open this category setting. And let's say like I want to divide by the 10, and then that means you're going to have the 10 bars. So this is exactly the same thing like what I did by using the wrangling step, but now that you don't have to, like you can just do that within the chart. And but the point here though is that like the label should respect the original sort of like a range number. So you don't want to see just because this range is high, has more value, you don't want to see them here or something. So you want to respect the original numerical value orders. Okay, so that's the beginning, the detail in the slides, but here's the last topic. And then this is, I have been presenting statistical learning, like a linear regression model for the last few sessions, online session. And then there is interpretation of the coefficient, right? So in the linear regression case, like in order to understand the coefficient, usually like a 1 point increase in the x-axis or in a predictor variable can expect a certain amount, in this case, the coefficient values increase or decrease in the y or the target variable, in this case, monthly income. And then, so if it's a numerical, let's say like age. So let's say like 1 year increase in age can expect like, let's say like $1,000 increase in monthly income. That's very straightforward to understand it. But then things get a little bit more complicated when you have the categorical as a predictor. So here in this case, a job role, and it says a job role research director. So like what is like 1 point increase in the job role research director can expect $4,000 increase in monthly income. But what do you mean by the 1 point increase in the research director? Because this is a categorical variable. Therefore, you always compare against base level. And then you can find the base level by going to the summary tab or coefficient.table. Then in this case, the base level job role is sales executive. So when you run the linear regression model or logistic or whatever the statistical model, behind the scene, it sets the base level for all the categorical variables or character variables in this case. And then how they pick the base level is based on the frequency. So like it turned out this data, we have most people in the sales executive job role. So therefore, sales executive being set as a base level. And then if you don't want that sales executive to be the base level, let's say like again, we want to use a research director as the base level because we happen to be more familiar with the research director. Then you can change it. This is exactly the same thing we did already for the chart when we talked about window calculation. So like you can use the same function FCT_read level, or access this from a column header menu, and then select the research director and then first level. And this, by doing this, like you go to summary view, you can see the base level is set to research director. Then you go and then you can rerun the model. So for example, like when we go to here, analytics, and then right now when I run here, and then all the stuff we see is comparing against the sales executive. because this data is coming from the step one. This is before we change the levels of the job role. So therefore, if I go to summary view, and then the base level job role is still sales executive. If I move this pin to the second step, that's where we set the levels and the base level to be research director. And then we can rerun this model. And then now the base level is set to research director. And then when I go to the coefficient, here the job level, not job level, basically most of the stuff, only the manager is higher, but this one looks like a confidence interval is covering on a 0, and also p-value is 0.55. Therefore, this is not significant. But most job roles here, for example, sales representative is minus 4,670. That's because compared to research director makes more money. So therefore, if your job is just happen to be sales representative, then you compare to research director, you can expect less, $4,670 decrease or something. Okay, so that's so this setting the first base level becomes more important, especially how you want to interpret that these coefficients in the linear regression, logistic regression, Cox regression, or any other statistical models. And that's where you want to use the factor data type. Okay, so that's it for today. So if you have any questions, please let me